Hi, I'm Ryan Baker, and this is Big Day in Education. Today we're going to continue our discussion of visualization by discussing state space diagrams. State space diagrams are visualizations of all the states that the learning system can have during a problem or other learning activity. A state is a complete characterization of the situation. Anything you have to know about the current state of the simulation, what's currently in it, whatever the player has done. And these are also referred to as student learning pathways or interaction networks. Lots of names for them. Also state space networks. Let's talk first about state space diagrams and refraction, popular online game played by tens of thousands of kids, and this is work by Taylor Martin and her group. If you look at it, refraction is a game where you have to divide fractions and you have to place operators. In this level, students are still learning the user interface. You can see the laser is being shot into the rocks, and we actually want to get it into the goal by the side. So this is the initial state, and you can see that little circle off to the side, representing the initial state. The second state you might see is if the player places a left bender. Now the beam bends to the left, and you can see we have a link down from the initial state to state 2. Then we do a bender to the right, and now we have a third state. And you can think about the transitions between the states. From single state, nothing there, to now we've added the left turn, to now we've added the left turn and the right turn. And these can show single student trajectories. For example, here's a successful student on one problem in refraction. This is from Taylor Martin's work. You can see that the students started in a certain state. They then went to another state. In that state, they kind of made changes that stayed in that state, went to a different state, made changes that stayed in that state, went to a different state, made changes that stayed in that state, went down to the very bottom. They came back from there and then went to the success state. An unsuccessful student, by contrast, has a much less linear pattern. This student goes back and forth endlessly between a small number of states. I like this kind of like curving out lines. They really show how much the student is going in circles. Beyond just showing a single student, these diagrams can be used to show all the paths through the system, and they can be used for more complex systems, as has been seen in some of the work by Matt Johnson, Matthew Eagle, John Stamper, and Tiffany Barnes. So in this case, this is the entire student path through a logic simulation, a logic Turing system. You can see the start state up at the top, and thicker lines mean more students went down this way. At the very bottom there are these green boxes that represent success states. So you'll see that there's a whole lot of ways to get to a success state in this simulation, and students take some paths much more than they take others. So what are state space diagrams used for? Well, first of all, as I mentioned in the case of refraction, to study specific student trajectories. See which paths end up being productive, as in the work by Barnes's group, and see which paths are rare despite being productive. If you go back and look back in the video, you'll see that there were some paths to the correct solution that had very thin lines. Not many students took them, but they were still okay. This can also be used to make recommendations to students, hints based on their path, which John Stamper worked on in his doctoral dissertation. And in this case, what it actually does is it says, gee, what is the most common path out of the current state that leads to a correct solution? Let's try to suggest the student does that to try to get them forward. So that's it for state space diagrams. In the next lecture, we're going to discuss some other visualizations of educational data. It'll kind of be a magical mystery tour through other visualizations. So thank you very much. I'm Ryan Baker. This is Big Day in Education. See you next time.